Relatively quick, 15, 20 minutes at the most. What time do we get out of here today? 53? Yeah. Okay. So yesterday we learned how to write hypotheses, a null hypothesis, and an alternative hypothesis. So today we're going to talk about what we're going to kind of do with those next. So ultimately, we're going to use the null hypothesis, always the null, so that's the one with the little h sub 0, to make a decision about whatever claim is being made. And the two things that you're going to do at the end of a hypothesis test are either reject the null hypothesis or we say we do not reject the null hypothesis. I kind of relate this to being like guilty and not guilty in the court system. We never say somebody's innocent in the court system. We just say they're not guilty. So it's the same thing with rejection. We either reject something or we do not reject something. Okay. And we'll base our decision based on calculations that we'll do later. No calculations today. Okay. So based on decisions that are made, whether what we're claiming is true or false, and whether we decide to reject it or not reject it, errors occur. So that's what our lesson's about today mostly, is a type 1 and a type 2 error. So a type 1 error is when the null hypothesis is rejected, but it is actually true. Okay, so when we reject something, we're saying we have enough evidence to say that it's not true, but it is actually true. Type 1 error. This out of the two is considered to be the more serious of the two errors. And you'll see why when we see some like real life examples, okay? A type 2 error is when the null hypothesis is not rejected. So it's like a not guilty verdict, but it's actually false. So we'll see an example of what that would look like in the court system in a little bit, okay? So the table at the bottom kind of describes the decisions that are made and the errors that can occur. So we, again, are always basing our decisions around the null hypothesis. So the null hypothesis is either true or false to start. And our tables are always going to be set up this way, just so the errors are going to occur in the same locations. It's going to be easier to find them. So we're always going to put null hypothesis being true on the left, null hypothesis being false on the right. Then the decisions that are being made on the side are, again, going to always be in this order. We either do not reject it or we do reject it. Okay, so then in the middle, if the null hypothesis is true and we do not reject it, that is a correct decision being made. Okay, so our math supported what is really happening in real life. Okay, or the null hypothesis is false and we reject it. Ultimately, this is going to be the goal of a researcher, is they're trying to prove that something's false by rejecting it. Okay. Then the type 1 and type 2 errors. And again, you can kind of see based on the definition at the top there what these mean. So if the null hypothesis is true and we reject it, that's where we see the type 1 error occur. And if the null hypothesis is false and we do not reject it, that's where we see that type 2 error occur. All right, so in the next slide, we've got some examples of common real-life situations where we see type 1 and type 2 errors occur. The most common example, if you Google type 1, type 2 error, is the court system. And again, it all goes back to our null hypothesis to start. So what do we assume when someone goes to court? We assume, you know, not guilty or innocent until proven not guilty, or guilty, right? What do we say? Innocent until proven guilty. Okay, got it. All right, so our null hypothesis is they are innocent. So at the top, we've got the real truth. So in reality, this person is either innocent or guilty. So innocent says that the null hypothesis is true, because that's what we're assuming. And guilty says that the null hypothesis is false. Okay, when we say then that the jury decides they are not guilty, that is equivalent to not rejecting the null hypothesis. And when we say that someone is guilty, that's equivalent to rejecting the null hypothesis. Then what you see in the middle are things that are actually going to happen then based on those decisions that are being made and the truth about the defendant. So if the defendant is innocent and the jury comes back and decides they are not guilty, justice has been served, the correct decision has been made. Or if the person is guilty and the jury decides that they are guilty, then again, justice has been served, the correct decision has been made. Thank you. Okay, in the other two boxes then, we're going to see our errors occur. So if someone is guilty, but we do not have enough evidence to prove it, jury comes back and says they are not guilty. So we do not reject a false null hypothesis. That's an example of a type 2 error. Or if the person is innocent and they are proven guilty, that's a type 1 error. You can see, I think at this example the best, why the type 1 error would be more serious. Both are bad to happen, but if we send someone to jail that's innocent, guilty of a crime they didn't commit, that's a pretty serious error that's occurring. Okay? Any questions so far? Okay, so let's fill out another one. Our null hypothesis here, another common example is medical testing. So we're going to use COVID-19 because why not? So you are COVID-19 negative is our hypothesis. Okay, so the truth about, we'll say, your COVID-19 status. So the first box is that our null hypothesis is true, okay? So our null hypothesis is that you're COVID-19 negative, so the truth is that you do not have COVID-19, okay? Or the null hypothesis is false. So if you are not negative, that means you have COVID-19, okay? Then on the side, how would we determine that? Usually with test results, right? Some type of medical testing, rapid tests, send away tests, whatever they decide to use. The first one is when you do not reject, okay, which would be equivalent to a negative test. And the second one would be rejecting, which would be equivalent to a positive test. All right, so let's decide what this means. If you don't have COVID-19 and the test result shows that you do not have COVID-19, that is correct. Okay, so tested what it was supposed to do. Or if you have COVID-19 and the test shows you have a COVID-19, that is also correct. But if you have COVID-19, but the test result shows that you're negative, that is what we call a type 2 error. And in the medical community, that is a, probably have heard this before, false negative is a type 2 error. Okay, and it can be any type of testing. We're just using this specific virus as an example. If you are negative, but the test shows that it's positive, that is a type 1 error. And that is a false positive. So those were words that were thrown out a lot, right? Like a couple years ago when testing first came out, what's the percentage of false positives, false negatives, and they were determining the validity of the tests and the probability that that would happen. And we obviously want the probability of both errors to occur be as small as possible. Okay? Any questions on that? All right, I have a, I think, cute little video to show you about type 1 and type 2 errors. At the beginning, he's going to talk about alphas and betas. We'll talk about alphas later. We don't get into betas in this class, but the example at the end talks about, in real life, again, another situation where you would see a type 1 or type 2 error. All right, let me see if my thing wants to work there.
In this lesson, we will learn about the errors that can be made in hypothesis testing. In general, we can have two types of errors, type 1 error and type 2 error. Sounds a bit boring, but this will be a fun lecture, I promise. First, we will define the problems, and then we will see some interesting examples. Type 1 error is when you reject a true null hypothesis and is the more serious error. It is also called a false positive. The probability of making this error is alpha, the level of significance. Since you, the researcher, choose the alpha, the responsibility for making this error lies solely on you. Type 2 error is when you accept a false null hypothesis. The probability of making this error is denoted by beta. Beta depends mainly on sample size and population variance. So if your topic is difficult to test due to hard sampling or has high variability, it is more likely to make this type of error. As you can imagine, if the data set is hard to test, it is not your fault, so type 2 error is considered a smaller problem. We should also mention that the probability of rejecting a false null hypothesis is equal to 1 minus beta. This is the researcher's goal, to reject a false null hypothesis. Therefore, 1 minus beta is called the power of the test. Generally, researchers increase the power of a test by increasing the sample size. This is a common table statisticians use to summarize the types of errors. Now, let's see an example that I heard from my professor back when I was studying statistics at university. You are in love with this girl from the other class, but are unsure if she likes you. There are two errors you can make. First, if she likes you back and you don't invite her out, you are making the type 1 error. The null hypothesis in this situation is, she likes you back. It turns out that she really did like you back. Unfortunately, you did not invite her out because after testing the situation, you wrongly thought the null hypothesis was false. In other words, you rejected a true null hypothesis and lost your chance. It is a very serious problem because you could have been made for each other, but you didn't even try. Now, imagine another situation. She doesn't like you back, but you go and invite her out. The null hypothesis is still, she likes you back, but this time it is false. In reality, she doesn't really like you back, that is. However, after testing, you accept the null hypothesis and wrongly go and invite her out. She tells you that she has a boyfriend that is much older, smarter, and better at statistics than you and turns her back. You made a type 2 error, accepted a false null hypothesis. However, it is no big deal, as you go back to your normal life without her and soon forget about this awkward situation. Hypothesis testing is usually like that. You don't really want to make any of the two errors, but it happens sometimes. You should be aware that statistics is very useful, but not perfect. Alright, that's all from our love/life/statistics lesson. Thanks for watching. For more videos like this one.
I thought that was cute. All right. So we're just going to do one of these on the next slide. So we have a null hypothesis, and we just want to describe what the type 1 and type 2 errors are in it. So we'll start with the type 1 error. So the claim is that a bookstore says at least 60% of its customers will return to buy another book. So type 1 error is when the null hypothesis is true, but rejected. Okay, so in this example, it's true that at least, so greater than or equal to 60% of customers return to buy another book. But research, survey, sample, whatever was done, showed that to be false. So the bookstore's claim was rejected, even though it was really true. So maybe they did a sample and they showed that only 48% of customers returned to buy a book. So then they rejected the hypothesis that was being made. A type 2 error is when the null is false, but not rejected. Okay, so it is false that greater than or equal to 60% of customers return, but research, survey, data, sample, whatever, showed it to be true. Okay, so maybe they did a sample of 30 customers and 75% of those 30 came back to buy another book. So then they decided, based on that null hypothesis that was being made, we are not going to reject it. We're going to accept it. All right. Any questions? Okay, we won't do the second one. It's basically the same thing. All right, last little part of this lesson is going to kind of build into Monday's lesson and then into 7-2 when we get to that section. So when we create a hypothesis test, we write a null, we write an alternative, one of them is the claim, and then we need to decide whether we're going to reject or not reject at the end. How we make that decision is with a level of significance, and level of significance is going to be that alpha he was talking about in the video a minute ago. The smaller your level of significance is, the less likely you are to make one of those errors, a type 1 error, a type 2 error. So the most common levels of significance that we use are 0.1, 0.05, and 0.01. And you guys probably have seen those on like your Z and T tables that we've done before, so we're going to be coming back to those later when we start doing the math. So the smaller alpha is, the less likely you are to make an error. So like 0.01 would be ideal. But it's also possible that we don't reject something that we should reject, or do reject something that we do not want to reject. So it's kind of like the confidence interval stuff where we walk a fine line, right? Like confidence intervals, we wanted it to be a good estimation, but we didn't want it to be too big. Same thing happens here. So there's not like one number that we always use. We kind of go back and forth, but these are the most common ones, okay? All right. When we do the testing, we're going to be testing just like we did with confidence intervals for population parameters of the mean and the proportion. And then you have your sample mean and your sample proportion, and we'll talk about those later. Then, based on the calculations we do with that mean or proportion, we're going to look at our hypotheses that we created, and then our standard normal table when we're talking about a mean, because that's what we're going to do first. And we're going to use a p-value, a probability value, with our hypothesis test to determine if we're going to reject or not reject. And Monday's lesson gets a lot more into this. But for right now, what we want to focus on is, based on the way the hypotheses are written, what type of test is created. Okay, so there's 3 cases, and we saw all 3 of these cases yesterday. The first case was where the null hypothesis was greater than or equal to a number, and these are all means because that's what we're going to do first, but it could be another population parameter. And the alternative was the complement, less than. That creates what's called a left tail test, and the way that I remember that it's a left tail test is the alternative hypothesis. The alternative hypothesis will point in the direction of the tail that you're going to be looking at for the hypothesis, okay? So the alternative hypothesis says less than, and you can see the shading that we have is in the left tail. It's less than a specific z value that we'll be calculating. What that region in the left tail is going to tell us is it's eventually going to be called a rejection region. And if we have another value within the rejection region, that tells us to reject. And if we have a value that's not in the rejection region, we do not reject. And alpha helps us figure out how big the rejection region is. Okay, but for right now, that case, left tail test. Case 2 is where your alternative hypothesis is greater than. That creates a right tail test. So the rejection region, the area that we're going to be using, our probability value, our p-value, is all going to be on the right side. And then the third and final one is our equal to, not equal to case. That creates a 2-tailed test where you're going to have an area on the left and on the right that are going to make up our rejection region. So the last slide we're going to do is we have an example. We're going to write the hypotheses, so that's a review from yesterday, and then we're going to determine, is it a left tail, a right tail, or a 2-tail test, and then just shade a standard normal curve to match that. So the first one, a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, so this is a proportion that we're writing the hypothesis about, so that's going to be a P that we're using. And then this one's a little tricky. It says students who are involved in at least one extracurricular activity is 61%. Is 61% is the important part. This stuff here, who are involved in at least one, that's just what it represents. So don't get too stuck on the at least part. Yes. I'm sorry, what? Oh, yes, you're like way ahead of me. Okay. Yes. 2-tail. We'll come back to that. All right, we first need to write the hypotheses. Okay, so the claim that the school is making is that a proportion of people who are involved in at least one extracurricular activity is 61%, equals 0.61. Okay, and is that a null or alternative? That is a null. Okay, the alternative then, what's the complement of that? P is not equal to. Okay, and then equal to, not equal to, Brody already said it's a two-tailed test. So eventually, we're going to have shading on the left and the right tails, and that's going to create our probability values, our areas, our rejection regions. We'll call it a few different things there. Okay, that's all you have to do for that. A car dealership announces that the mean time for an oil change is less than 15 minutes. All right, so this is a statement about a mean is less than 15 minutes. Claim. Mean less than 15. Is that a null or alternative? That is a alternative. How do you know it's an alternative? Just less than, not equal to. The null then is the complement of that. So if I'm not less than, I'm greater than or equal to. The alternative hypothesis, whether it's a claim or not, tells you which type of test it is. So is it left tail, right tail, or two tail? This is a left-tailed test. Okay? That's where we're going to stop for today. 7-1 day 2. All right, so you guys have a little less time than normal, and we have short periods today, but you got about 15 minutes if you want to work on 7-1 day 2 as myself. On Monday, I am not here, so you guys are doing what? I know. My son has a doctor's appointment on Monday. He's starting allergy shots. And it's the first appointment, so we have to do like a bunch of testing. So it'll be every week, but I won't miss school every week. It'll be like but tomorrow's the first one, or Monday's the first one. Okay, so anyway, on Monday, you guys have an 18-minute video linked in the way. If you want to watch the video this weekend, just to have it done, you can, and then you can just do homework on Monday. It's already there. If you just want to watch the video on Monday, that's fine. 13 is my cell phone lotto winner. Okay. Yeah, you're welcome.